Welcome to another lecture on engineering mechanics. Today we will discuss laws of friction. So let us start the lecture. In the previous lecture we have discussed about different concepts of friction, and from those concepts we have concluded certain important points, and we will call those points as laws of friction. So let us see the summary of those points in this lecture. So let us start with the first point. Friction always acts to oppose the motion of free body or its tendency to move. It acts tangential to the surfaces in contact. If static friction is acting, the value of the frictional force may vary from 0 to the maximum value available, depending upon the resultant force tending to cause motion. The maximum value of static friction, that is the limiting friction when motion is about to take place, is equal to μs n, where μs is coefficient of static friction, and we denote limiting friction or maximum static friction as Fm. Next is the maximum value of available friction force Fm is independent of the area of surfaces in contact. This is a very important point to understand. It only depends upon the coefficient of friction, that is mu. If kinetic friction is acting, the frictional force is constant at its limiting value, and its value is given as Fk is equal to mu kn, where mu k is the coefficient of kinetic friction and n is the normal pressure acting on the body. The angle between the total reaction and its normal component, that is the normal pressure, is called the angle of friction. The tangent of this angle is known as the coefficient of friction, and we call that as tan phi equal to mu. So mu is the coefficient of friction, which is the tangent of angle of friction.